Welcome to Industry Tech Days 2021, brought to you by EE Tech Media and All About Circuits. I'm Daniel Bogdanoff, your host for this event, and welcome to day 2. Thanks for being here. In today's keynote, we're going to chat live with history-making astronauts. Industry Tech Days 2021 is a free 5-day virtual conference and trade show for engineers and technologists like you. Each day kicks off with a keynote from an engineering rock star, followed by a lineup of live sessions featuring industry experts, professional training, and interactive Q&As. You can also browse one of the 30 digital booths from your most trusted manufacturers and distributors, and of course, there are over 100 giveaways. 100 people will win a soldering mat and a t-shirt, and one lucky attendee will win a grand prize from DigiKey Electronics, a fully loaded InstaLab kit, including test gear, tools, components, and more. The more live sessions you sign up for, the more chances you have to win, and you can sign up for all 50 sessions right now on the event webpage by going to allaboutscircuits.com and clicking the Industry Tech Days link along the top menu. Scroll down on the page and you'll see a schedule of this week's live keynotes and sessions. You can also watch sessions on demand after the fact. For example, if you missed the keynote yesterday with Arduino co-founder Massimo Bonzi. Live sessions kick off right after this keynote. A couple topics that stood out to me from today were 5G millimeter wave beamforming, ultra low power Wi-Fi for IoT, and one on edge computing trends. There's a bunch more. You should go check them out. Today's keynote is brought to you by Avnet. Avnet is a leading distributor of electronic components that has serviced the electronics industry since 1921. Avnet works as an extension of your team to help you accelerate your design and scale operations as you move into production and extend your product throughout its lifecycle. For more information, visit avnet.com. Now, if I told you that someone had traveled 250 miles, you probably wouldn't be that impressed. But if I told you that it's 250 miles vertically, straight up into space, and then they docked with a $150 billion pressure chamber floating at 17,000 miles an hour, I hope that would get your attention. Colonel Mike Hopkins and Commander Victor Glover Jr. can make that claim, and they are here today. They were both part of the historic first crewed flight of a SpaceX Crew Dragon spacecraft that launched in 2021 and just got back to Earth in May. This is one of their first interviews since they got back, and even though they are here back on terra firma, I have to say this session is going to be out of this world. Victor, Mike, hop on the stream. Thank you so much for being here. I'm honored to spend the next hour with you. Can you introduce yourself and tell everyone how you got started as an astronaut?
I'm Colonel Mike Hopkins, U.S. Space Force, previously of the U.S. Air Force. So I joined NASA in 2009. It was after 4 tries over the course of 13 years, and then was finally selected and was privileged to join the 2009 class. I do have flight test in my background as a flight test engineer. And so again, I spent most of my Air Force career doing that. Then selected by NASA, had the privilege of flying as part of Expedition 37 and 38 back in 2013, 2014 on the Soyuz, and then again most recently this mission on Crew Dragon as part of Crew 1 and Expedition 64 and 65.
And I am Navy Commander Victor Glover, NASA astronaut, and I joined the astronaut corps in 2013 after being a naval aviator and test pilot. I was fortunate to fly the F-18 Hornet and the Super Hornet and the Growler a little bit in test, and really enjoyed those things. I flew in combat in Operation Iraqi Freedom, and I was working in Congress. Was able to do something a little different. Instead of working in the Pentagon, I opted for a staff job working for a senator. And so got to work in Congress for a year, and I was actually 9 months into that fellowship when I got the call to come down to Houston and start astronaut candidate training. And so I've been here since 2013, part of the 8 balls, 8 candidates selected, 4 men, 4 women, and most of our class is flown, and we've got a couple people in the hopper to fly. In the hopper, getting ready to fly soon. Things go well, and it's been a really interesting 8 years. Actually, the day after tomorrow is the 8-year anniversary of when I started working at NASA.
Fantastic. And Victor, how did you know that you wanted to be an astronaut?
Well, good question. So there's a little nuance here, and actually it started. I didn't want to be an astronaut. What I wanted was to fly the space shuttle. So I saw a launch of a shuttle, and I can't tell you exactly when it was, what mission. I was about 10 years old, and I saw it on television, and I thought to myself, well, I'd love to drive that. I wanted to be a race car driver, stunt man, a police officer like my father. And so you can, I've always had maybe an extra sensitive sense of adventure, and I wanted to do all those things. And I saw a shuttle launch on TV and thought, actually, the thought was I'd love to drive that thing. I didn't even know pilots and enough to think that you had to be a pilot or to be an astronaut, but I just thought I want to control that machine. And so that's where it began. And that grew with me over the years, learning about aviation and engineering. And I actually was on my way to becoming a test pilot. I was in test pilot school, and I saw Pam Melroy, who's now our deputy administrator. I saw her give a talk about her mission, and I thought, you know what? I am throwing my hat in that ring. It was very motivating listening to her talk about not just the technology and the operations, but the respect and the camaraderie of their crew. I really thought that's something I could, toss my hat in the ring for and see what happens. And so I actually applied for Hopper's class in 2009, or started in 2007, and didn't get anywhere in that one. And then I applied for the next round in 2013, and every dog has his day.
You mentioned being a fighter pilot, and you probably know what I'm going to ask, but can you tell us about your call sign and how that came to be?
It's a long story. I'll say this: I earned it. I can be opinionated, and so I showed up to my new squadron, and it wasn't surprising to anybody when my commanding officer. We have these really cool ceremonies. They're a lot of fun. We call them call sign review boards. It's a tradition in aviation and most of the flying services. Air Force does them, Navy, Marine Corps, and so it's usually run by the younger officers, though. And so it's really interesting that my commanding officer gets up, and he, there's all these other options on the board, and he goes up and he puts ITIKE. And then he goes and sits down. And so everybody, all the other junior officers are like, you want to explain that one, sir? And he says, I think I know everything. Questions? And we voted, and it was unanimous. Everybody agreed that was going to be it. And that ceremony was run by the senior junior officer, and a good friend of mine. He goes, well, Skipper, I think, for brevity's sake, we'll shorten it to Ike. So IKE is what it actually wound up being officially. I know everything, but it's a reminder to keep my opinions to myself when I can.
So is it flattering, or is it kind of like obviously not embarrassing, but are you proud of that, or is it something that is like, well, this is the moniker that I now have?
Oh, well, it's a lot of things. I think it's not so much whether it's flattering or not, because call signs are generally some form of it's one of the ways that we get the outcome we want in the fleet. It's a part of training, if you will. It's not F-18 training, but it's like cultural training. This is the culture we want, and we're going to use every tool we have to get it. But also, I've had it now since that squadron I joined in 2003. So I showed up, and my call sign was Rubber Glover, just based on my last name. And so, I think that whatever call sign you get after we jokingly say any call sign you take into combat with you is yours forever. And so I did go into combat in that squadron, and I took that one with me. So it's obviously special to me. But you know what? It doesn't matter if they called me, they could have called me whatever. They could have kept calling me Rubber Glover. But when they paint that name on the side of a jet, and you get to fly a jet that has your name painted on one side, I mean, that's pretty amazing. So any call sign that people are going to use because you're flying squadron mates with them, I think you're doing pretty well. There are worse
That makes
things
sense.
than having a bad call sign.
That makes a lot of sense. I love that we have Mike and Ike here as the as the dynamic duo. Mike, how about you? How did you know? You said you tried a couple times to become an astronaut and it didn't pan out for you. What made you keep going? Why is this something you chased after?
Yeah, well, so for me, it started. So I mentioned that he was watching a launch when he was 10 years old. Well, I was in high school then. I was finishing up high school at that point. So, but watching those launches, watching those shuttle missions, and this is the early days of the shuttle that we're talking about. At that time, they used to actually, bring a lot of the kids into the auditorium at school, and it'd be that old TV, the old cathode ray tube TV, as big as they could get it, and they would show the launches and like the spacewalks and things of that nature, and kind of like Ike, he says, I want to drive that. And for me, it was I want to do that. I want to do that mission. That
Yeah.
just looks like something I would like to do, something that would be very fulfilling to be able to do. And so it just, from that point on, it kind of stuck as a long-term goal. And then you have to kind of figure out, what am I going to do in between? Because there is an in between. There is something that you have to figure out what you want to do in the interim. And in fact, it's most likely for most people is something that you're going to end up doing for the rest of your life. Because I think Victor and I would both say we're very fortunate to have gotten this job. And so for me, I was also interested in aviation though, and went into aerospace engineering, got into the flight test, as I mentioned as well. And so throughout that whole time, I'm absolutely loving what I'm doing in the Air Force, getting to test airplanes and fly in airplanes. And at the same time, I kept pursuing this goal of becoming an astronaut. And just, I was very fortunate that it finally worked out.
So you both did a lot of work testing planes before you were astronauts. Can you talk about and compare pulling a lot of G's to effectively pulling 0 G's in space? How that's different and how that's maybe the same.
Well, I'll let Ike start with that one, since he's probably pulled a lot more G's than I have throughout his career.
Well, I have been fortunate. I just got back off a vacation and drove to California to visit a lot of family. And so, you know what question I was asked a lot? What launch felt like in pulling those G's. And so it's interesting that, the most G's I've ever pulled in my life is in a centrifuge training. And we did a centrifuge that matched our profiles on ascent and entry. And so that was great exposure. But the most G's I pulled operationally were in a fighter aircraft, 8, 9 G's, but that's only for a few seconds. And so, first, before you can live in weightlessness and be in a 0 G environment, you have to go through high G's to get there, because you have to get to such a high speed to hit orbital velocity. And so our launch, was roughly 10 minutes of accelerating, starting from straight up. And then once the rocket tipped over and the upper stage tipped over, that's when you really just start, accelerating. And we were above 3 G's for minutes. We were above 4 G's for several seconds, maybe even a couple minutes. And we peaked out just
Mm-hmm.
under 4.5 G's. And what was the most impressive about that? While I pulled more G, I've never pulled a significant amount of G for roughly 10 minutes. And so at staging, when the first stage turns off and disconnects, flies back and to the land on the ship, and then at second stage, engine cutoff. Other than that, you're accelerating the whole time, and that was really impressive. I mean, it there was so much power right there behind us, that it was amazing. In entry, it was the same thing in reverse. You felt those same forces because our spacecraft turns around. On entry, we're facing into the wind. On launch, we're facing the wind. On entry, we're backwards. So the G forces feel the same. They make your face do this both times, and that was just amazing. And then between those two, for 167 days, we lived on the space station in microgravity. And for me, it was the first time I got to experience that. So from the first moment in Dragon, inside Resilience, to every day, it's amazing. I tell you what, there's nothing that prepares you for going to sleep and then waking up in both in weightlessness. I mean, to live in weightlessness and work in weightlessness was truly an amazing life experience. And I'll let Hopper talk more about that if he wants to.
Yeah, he describes the what it was like, those sustained G's and all of that. And the one thing I'll say about that though is we can relate to that. Even though it was different, both of us have experienced G's in the fighters before, and so you know what you kind of expect. But what I will say is 0 G, we don't have any reference for that. I mean, it is so unique, and it's just hard to get your mind around it when you finally get up there and you experience sustained G's. There's no reference point for us down here on Earth. It's not like we train in the pool, for example, for spacewalks, and that works pretty well. But you still know G is there, right? You're still feeling Earth's gravity, because if you flip upside down, you feel the blood rushing to your head, all of that. So being up there and living in zero G, it's not like swimming in the pool. It's not like flying. It's a bird or anything of that nature. It's different, and it's hard to explain. And that's what's really interesting about it, because it's what makes going to the International Space Station, going into space so unique, is being in this zero G environment. And yet it's so hard to describe. It's so hard to describe what it is really like. And that is something that I have struggled with from my first flight back in 2013. And even today, it is still hard. And one of the sad things about it, man, is after you come back, it's hard to remember too what it's like. You have to go back and look at the videos and see yourself and go, wow, I was really doing that. And sometimes it's hard to remember what that experience is like, sadly.
Was it really nice to come back and just like drink out of a cup? Were there other things that were just when you returned home that you were so happy to be able to do again, other than, being on Earth and with your families and eating homemade food, that sort of thing?
Everything about being back on Earth is good to be able to do. I know Ike will probably talk about it, but being able to drink out of that open cup, like you said, because drinking your coffee, or in my case, my tea, it's an experience, right? It is not just the drinking of the tea; it's the having that nice warm mug, having the aroma coming up as well, and you don't get that in space, right? Because it's all in a bag. You're drinking through a straw, and that's just not quite the same experience as sitting out on your back porch watching the sun come up with that nice hot mug of tea or coffee. And so I would say when you get going away, leaving Earth, going up into orbit, one of the things it did for me was make me appreciate every little thing about being back down here on Earth. I mean, the week after we returned, and I'm sitting on my back porch, and you're just sitting there, and you're just listening to the wind, and you're just listening to the sounds of bugs and birds, and all of those little things that you don't get when you're up there on station. And so I appreciate everything about being down here in the 1G environment.
Yeah. Yep. Well said. Well said. It was really nice to drink hot coffee out of a mug. It took me about a month to drink coffee on the space station because of the smell. Without the smell, it was a different experience. And so, yeah, that was definitely one of the things I've enjoyed about being back on Earth. In addition to just being with my family and being back to normalcy, flying, floating, it was great. It really was. And while I was there, sometimes floating was awesome because you could push off of one side of the module and float until you hit something, essentially, but it also made things challenging. You'd open a bag and everything wants to come out. And so I used to talk to my family about space Tetris. Putting things in a bag has challenges when you're doing it in weightlessness. And so all those things, though, I knew at the time, I kept telling myself this won't last forever. And so I tried to enjoy every moment of it. And I did. And it's hard to describe because it isn't like anything it's like try to describe fire to someone. Try to describe fire. It's really complicated to describe fire and get that image and the smells and the feeling into someone else's head. And so the best thing I can say is floating, living in microgravity and weightlessness is like living the dreams that we have about flying. I mean, when you dream about flying, most of us do. We got to live that for almost 6 months. And that's the best I can tell you, because everything else that I could describe is going to attach it to the wrong thing. It's got acid. It's kind of like ice skating, how you can keep going for a while, but it's not like ice skating. It's kind of like swimming in terms of being supported. But if, like a hopper said, if you flip upside down in the pool, blood still rushes to your head, water goes in your nose. So it's not like swimming. It's its own thing, and it was amazing.
One more question for you about gravity, and then we'll move on. I know most of our audience is engineers, so I want to get to some of the engineering tech stuff. But I watched your launch with my little girls, and I think a lot of the nation did. And we were tickled by your choice of zero-G indicators. Can you explain for those who don't know what a zero-G indicator is and why you chose the one that you did?
Yeah, so I mean, the zero G indicator, the tradition of that goes way back from the early days of human spaceflight, and it was the idea was just something that was meaningful to the crew, that gave you that indication because you're all strapped down, that when you get up into orbit, when the engines cut off, that yep, everything, we're really floating. We may not be able to experience it because we still have the restraints on and all of that kind of stuff, but that's just that verification that yep, we are actually in space and we are orbiting. And so for us, as you can imagine, most of us are space geeks. Most of us love the space type movies and TV shows, and certainly Star Wars is one of those that we enjoyed, and The Mandalorian was one of those that we enjoyed, and then quite frankly, how can you not love Baby Yoda? I mean, so it was just one of those things. We had an idea of sitting around. In fact, it may have been we get together throughout training, and we spend a lot of time together throughout training before the mission itself. And so there was just one of those occasions as we're talking about, what do we want to use for a zero G indicator, and Baby Yoda came up, Grogu, and it seemed like everybody was kind of on board with it. So we went with it, and it was a lot of fun.
It's such a great moment because it's this historic flight, and you are the first people ever on to crew this capsule from an American, non-government organization, and then out comes this little Baby Yoda doll floating around. It was just a really great moment, I think, for everybody watching, and I'm sure for you as well. To switch gears a little bit, you both have advanced engineering degrees of one type or another. Mike, you have a master's in aerospace engineering from Stanford. Victor, it looks like you have 3 master's degrees: flight test engineering, systems engineering, and military operations art and science. Can you talk about why are there so many engineers and so many engineering backgrounds that end up on the space station and in space? Victor?
Yeah, I think it's because there is a need to the training that you get as a neophyte engineer, that academic background. I think you can break it down into these two simple things. It teaches you to critically think and analyze, right? And analysis is breaking things down. You can put things into simple, digestible parts. These big, complex problems, like the space station. Boy, what a crazy animal to try and learn, but we have to learn it so that we can, maintain and also respond in emergencies. But you learn processes for breaking things down into simple, digestible components. But you also learn synthesis, how to take simple, digestible, understandable pieces and put them together as solutions to those problems. And I would say living in microgravity, and I would imagine going to the moon and onto Mars is going to be very similar. Living on the International Space Station for 167 days was a continuous riddle to solve. There's always something to think about, to do better. I mean, after being there for 5 months, as we're preparing to go home, I was still changing my technique for doing blood draws and other things that I can talk about later. But you're constantly competing against weightlessness and against yourself, and trying to be better and to use the space station as effectively as you can. And so engineering and STEM, science, those backgrounds all I think are important at giving you a mental framework for handling these complex things. And so I talk about training for the space station. I think that educational rigor is very important. Not only, one, you prove that you have the stuff to do this job and handle it, even though it's not the most technical thing in the world. You do have that background, but it also gives you a foundation for going up there and being effective and efficient on the space station.
Mike, similar question for you. You were the mission commander. Can you describe what roles were uniquely yours as the commander, and how did you think through when a problem popped up, the mindsets and the skills of your different crewmates, how to tackle these problems that might pop up that you didn't expect?
Yeah, it's an interesting question, Dan, and I think one of the first ways to answer that is we had an amazing crew, and so what that allowed was, as the commander, I didn't have to come up with all the solutions because everybody on the crew, from myself and Victor and Shannon and Suichi, all of them had great backgrounds, great experience. And so the way we kind of divided the duties, and Victor and I actually, we had an opportunity to start training together much earlier than with Shannon and with Suichi because they came a little bit later. And so we had kind of broke down the duties, if you will, on Crew Dragon between myself as commander. I kind of took care of looking at the crew, looking at the timeline, looking at the mission. And then Victor was responsible for the vehicle. He was responsible for all the systems, tracking those, and so with him doing that, and me kind of trying and Victor was always keeping the big picture in mind as well. But that really helped us manage all of the different scenarios. And I got to tell you, probably one of my favorite moments during training, which I think gets to kind of where your question was going. We were in a sim, and we were in it was a rendezvous and docking sim, and we were at the point, the 20-meter hold point, and there were some issues with I think it was the camera system on board. And so we go into a hold there, and the ground team calls up and says, "Hey, we need to spend some time talking about this." And so we had some time, of course, on board as well, that we're analyzing the situation and we're thinking about what we're going to do next. And it was amazing because all I said was, "Okay, we're going to Mark Watney this." So if you've seen The Martian and Mark Watney, I said, we're just going to, you look at the first problem first, and then you solve that, and you go on to the next, etc. That is all I said. And then all of a sudden, I think it was Shannon mentioned something, and that triggered something from Mike, which triggered something from Suichi. And then all of a sudden, we had a plan of attack, and we called that down to the ground. And when we called that down to the ground, we had thought of some things that they hadn't had an opportunity to think of yet. And that was probably, I would say, for all of us, one of the most special moments during training. I think probably for all of us, one of the most proudest moments of our training is because, again, it was us coming together as a crew. It was not one single person having to come up with all of the answers. And I think from an engineering standpoint, from a problem solving standpoint, that is the way to do it.
I was kind of hoping you were going to say you were going to start growing potatoes on your sim, but that sounds like a more useful solution. What about if something goes wrong?
That's a later story.
Yeah, go ahead. Okay. Yeah, we won't go there. So if something, I'm thinking through how the potatoes were grown, but I think that might be out of scope for this conversation. If something goes wrong up in space, I imagine like inner space shipping is really expensive and complicated. What do you do when you need a part?
Like you said, getting things to space is expensive. We do send up things on cargo vehicles, and we try to spare out, but we have to think about it in a smart way. It's expensive to get things up there, and so you just can't have an unlimited store of things, but you need to have a certain amount. And then there are also consumables, things that we just go through at a certain rate. And so managing all that, we have a flight control position and then backroom support. There's so much work to do in that, trying to manage what things you keep on station. So we do sometimes have spare parts. We have a surplus of some things. We also have the ability, but right now it's mostly a technology demonstration and then a manufacturing demonstration. It's not really an operational system yet, but we have additive manufacturing. We have 3D printing capability on the space station, and we've used it to make a tool and to make parts. But mostly right now, we're making things that are visually representative that we take pictures of so the ground team can analyze the quality of these productions. But eventually that will be a way as well. But there's always the human in the machine. You have people there that in a pinch can innovate, and it's amazing what you can do with, a couple feet of rubber tubing, the right tools, some scissors, and duct tape. And we sometimes have had to innovate and make, solve problems on the spot. And so sometimes that's the way you do it as well. We had a small device we used to check for combustion products. So if we think there was a fire, it's a small pump that pulls air over the sensor, and so that pump had broken on while we were in space. And when I opened it up, the tubing inside had it's so old it was starting to just crack because of age. And so we actually took you were talking about growing vegetables or growing potatoes, but we grow vegetables in space, and one of the ways we do that is these big bags of water, and they have rubber tubes on them. And actually, I had to ask Mike for one of those, and he was using it to water our plants in space. But I needed to cut a section of it off to replace this tubing, and thankfully they were similar diameters, and we were able to. It was a repair that hopefully isn't permanent. We'll fly up a new system because it's important. This was a piece of emergency equipment, but that tubing was enough to get that device back working and operational because we only had two on the station, one in the Russian segment, one in the U.S. segment. And so now we had, or at least while we were there, we at least had one that could function. And so sometimes you have to make it with what you have.
Yeah. Question for both of you then. Mike, we'll start with you. What are there any moments that you are especially proud of that you'd like to geek out with other engineers, but maybe it didn't make a NASA press brief or headlines or anything like that? Are any of those moments that stand out for you?
Well, Ike, obviously he mentioned one situation that he was able to solve a problem. Kind of bigger picture from a geek out standpoint, engineering standpoint. And a lot of this, in fact, most of it was before Ike and I had even gotten there. But from an engineering standpoint, when you think about the International Space Station, none of the major components were ever tested together before they got to space. So none of the modules, none of the trusses, none of that was actually bolted together and made sure everything is aligned, all the holes are right, all of that kind of stuff. All of the electrical cables were the right length. None of that happened on the ground. All of that happened up in space. And so even though Ike and I never contributed to that actual building of the space station, every time I'm up there and I see that and I see some of the problems that we ran into while we were up there, it is truly amazing that the space station even exists in its current form because of the engineering that made that happen. And then from the other area where I think, in my mind, there's so much engineering on board. There's so many places that you can geek out. But one of my favorite areas of geeking out is when you're doing spacewalks, the EVAs, the extravehicular activities. And so, the things like the pistol grip tool that we use, the PGT, our cordless drill. That thing is an engineering marvel because it has to be able to go outside. It has to be able to work from, in this plus 200, minus 200 environments, as you're orbiting around the Earth. It's got to be able to last for 6.5, 7.5 hours while you're out there. Oh, and at the same time, you've got to be able to operate it with this big, your ski gloves on that are hard to squeeze and all of those kind of things. So there's those tools that are amazing and how they happen. And then when we go out on these spacewalks, oftentimes you have to just come up with some tools that don't exist. And so you're kludging together different pieces and parts that are on board station because you've got to, you got to go out the door and you got to fix this thing. And so when you get to see and this is a team effort because it is someone, thinking, hey, we've got this tool, can we use it? And someone else says, yeah, what if we combine those two together? And literally you'll see going out the door for spacewalks, tools that have been put together with tape, with wire ties, and you're going out and you're fixing $100 billion space station with these tools, and it works. And so from geeking out on engineering, I would say the spacewalk piece of it is one that I really get excited about, and a number of solutions that they've come up with over the years to get the job done is truly impressive.
I'm happy to hear that my excessive use of zip ties and duct tape to hold things together is space and NASA approved. Victor, is there anything that stands out to you other than the tube? I know you shared the pump already. Any other moments, engineers, that would just
that was definitely that was. Yeah, that was a fun one. It was a little pet project, and I enjoyed doing that. And I was trying to take pictures for the folks on the ground along the way, and that whole adventure was a good one. But like Hopper said, the big picture, there are so many technical things. The technology in the suits, people look at those and think of them as a suit, but it's also important to remember it is a spacecraft. It has a propulsion system, a life support system on the inside, visor that you're looking at. It's a spaceship. that can fly you around if need be in extremis. And it's pretty amazing when you think about all the things that it does, including the communication that we don't have to hit buttons for. We just talk and we can communicate with each other on the ground. But I would say one of the things that I found from a problem solving perspective to be the most enjoyable, I guess, is the problems that we had challenges that showed up. Some of them were on spacewalks, like Hopper said, but it was when we would attack them, like that sim he mentioned earlier, where we had a solution on board. And then we worked with the ground, and the ground had a piece of the solution. And it was when we all together came up with pieces of it that the final answer was some amalgamation of all of those pieces. Hopper and I were working on a valve installation. We were doing intermodule valves to a new module or a new section of the space station because we had put a new airlock on, the NanoRacks airlock. And we were outfitting these. And I mean, think of every kind of problem you can have. This thing ain't long enough to get to there. This won't fit in this orientation like it's supposed to be. It just there were lots of little issues for us to address, and we did. We Mark Watney'd it. We did it one by one, and we addressed them, and we got through them. And it was some onboard effort, some on the ground effort, and the flight control team, did a lot to be applauded. And so that, like, at the end of it, I actually went and wrote a note home to my family. Like, it felt really good to do that problem solving. I mean, between Earth and space. Like, it's pretty amazing because you don't always see everything that's going on in space. So just trying to understand or communicate what's going on in space can be a challenge. And so to get to the end of that, there were moments in the middle where I thought we're going to end this and not have success. And so to cross the finish line and actually have been able to install those and that they work was quite an accomplishment. It felt great.
So you've both mentioned spacewalks. Mike, you've done a few, and you together spent over 20 hours on spacewalks together. Can you talk about just the general feelings and emotions that you have as you go into a spacewalk, especially in a situation where you think it might not work? Because, after doing 3 total in 160 days, it's not like you just hop out the next day and take another stab at it.
Spacewalks it's almost like floating, right? It's hard to describe every kind of emotion that's happening when you're going out the door on a spacewalk, when you're going out that hatch. As you can imagine, you're very excited. This is something that most astronauts, if not all of them, is something that they want to do sometime in their career. And so to be able to do that is pretty special. So you're also very focused because the last thing you want to do when you go out on a spacewalk is lose a tool or you. So you're very focused on making sure everything is tethered and making sure everything is where it's supposed to be. And at the same time, you're very nervous, right? And that's understandable as well. You're going out into a very harsh environment. And as Victor said, you're going out in this little spaceship, this little spacecraft. And that's what's standing between you and an environment you're not going to survive if it fails. And so as you are somewhat nervous. You have to be. I can't imagine somebody going out the door on that and not having a little bit of butterflies in their stomach and that kind of thing. I would be very impressed if someone. I don't know how many spacewalks you'd have to do to have it become so commonplace to you that you're not a little bit worried when you're going out the door. And so that piece of it is very challenging. And it was interesting because for me, I did 2 spacewalks on my first mission, and then was fortunate to go out the door with Ike for 3 on this mission. And one of the big differences that really helped me this time around versus the first time around, and the first time, you got a lot of time just to get out the door. You're spending 5.5, 6 hours getting suited, doing the pre-breathe, getting your tools on, getting the airlock down to vacuum. That's a lot of time to sit there and think about what's coming up and what you're getting ready to do. And it's very easy to psych yourself out because you spend so much time. And so this time I took a little bit different approach, and it really helped me. And that was, I'm just taking it one step at a time. And I'm only going to be worried about this next step. And that next step might be I'm putting on my pre-breathe mask and I'm going to sit here for 60 minutes doing this pre-breathe. But I'm not worrying about anything else, but just making sure that I go through this pre-breathe step, and when it's done, I'm going to go to the next step. And when that's done, I'm going to go to the next one. And that just kept all of those other thoughts that can lead you down a bad path. That kept them out of my mind. And then the next thing you know, you're coming in the door 6.5, 7 hours later, and you've completed it. And so that was one of the ways for me this time around that it made a big difference in how I just felt in terms of going out the door and executing that piece of the mission.
Yeah.
Victor, what was it like to have someone who's done it before kind of walking you through
Yeah.
in real life what that's like?
It was great. I was very fortunate to have my first two spacewalks with Mike because we had done so much work on the ground. And so that one piece of familiarity when I was going into this environment that was totally new, even though the training systems on the ground in the neutral buoyancy lab we have here, they're phenomenal. It's still, there's no way to really prepare for going out into the real vacuum of space with nothing holding it up. I mean, it's all in orbit with you. And so it looks different. It looks similar to the one we train on. But so having that voice and my, working with Mike, we don't always even have to say the things. We just kind of know how each other works, and we go do the thing. And so that piece of familiarity helped. And Mike hit it on the head, focusing on one thing at a time. So I remember very vividly my very first spacewalk, and he opens the hatch and goes out. And then when I went out the hatch, I said, I'm not going to look down. I'm not going out to spacewalk. I'm going out to work. I'm going out to space work. And so I went out the hatch and I was looking at my hands. And then when I got out, I was looking at him. I checked him over. He checked me over. And then we went to work. He headed out and I had to put this big box on my suit and then go get on the robotic arm, which was another unique. So anyway, it was taking things one step at a time and being able to just quiet the mind and focus on that one thing. If you read Tom Wolfe's The Right Stuff, it's not about these fighter jocks that are able to just go light their hair on fire and do anything. It's they recognize the challenges ahead of them and they're just able to work through it. They have those feelings and those emotions and they're able to still focus and do the right thing. They're able to work through it. And I was focused on that. I just wanted to do one thing at a time. I know this handrail goes where I'm going, one handrail at a time. And that even by the end of it, so I got to do 4 spacewalks total, 3 of them with Mike. And on our last one, our very last spacewalk was the most challenging, in my opinion. It was lots of little tasks instead of 1 or 2 big tasks. And so we had finished up. He went one way and I went the other. And we had gone to do a task together with the ammonia line venting and then taking that jumper off. But then we split up and did a separate set of tasks. And at the beginning of that second task, wrestling that jumper, we had this big ammonia hose that I had to curl around a bag and then bring it back. And it was like I wrestled in college. It was like a college wrestling match trying to do that in microgravity outside the space station. And so by the time I got back to the airlock to get ready for the second activity, my hands were just worn out. They were completely tired. And I had the lactic acid burn going, and I'm sitting at the airlock, which is like home and safety, and it's light in there all the time, and I'm thinking to myself, I just want to crawl in there and stay. And I said, we're only a couple hours into it. We got a long way to go. And then I went, you know what? Nope. I only have to do this next thing. I have to get that bag in there and then get this bag out. And I just focused on that. And I actually had to do that entire spacewalk, the rest of that spacewalk. And it ended, if you remember this, Mike, it ended with us tying down that reel bag. That was the very last activity. And it sounds really simple. There are 2 of us out there, like you said, a bunch of education between us, degrees, training, tests, and all this flying fighters. And the last thing we had to do in the vacuum of space was tie down a bag. And it took every ounce of mental and physical strength I had. But I can tell you this, if Mike wasn't there and we weren't talking to each other, wouldn't have been able to do it. So it took all that capability and a teammate. And it was at the end of the spacewalk. It was night. The sun had just gone down. And it was just a really challenging moment. But again, we just did one thing at a time. You hold this, hook that. Okay, now we can unhook this. You got it. I've got that. Okay, and we tied it down. I mean, painstaking step by painstaking step. But I was tired. And, one of the things about that spacesuit that doesn't get much airtime is he told you we spend hours before we get in it and then we're in it for 6 to 7 hours outside the space station. So for that, period of, there's about 10 hours or so where all you have available to you is 32 ounces of water. And so your brain is at a calorie shortage. You're a little hypoglycemic at that point, and that's the time when you have to do the most important things, though, is at the end. Get back inside.
So you've both talked a lot about focusing on what's very next right in front of you, but I want to look a little farther out now. The NASA Artemis program sounds incredibly exciting, sending people to the moon for the first time since 1972, out of low Earth orbit. The first time out of low Earth orbit, with the first launch of that coming, I think, in November 2021. So that's coming up. Can you speak a little bit about, Mike, we'll start with you, about what it means to pursue sending astronauts to the moon again?
Yeah, I think, as you said, it's extremely exciting time. And there's a couple things I like about, to think about in terms of, from an astronaut's perspective, and then maybe something a little bit more global. And so, from an astronaut's perspective, when you sit there and think about having an opportunity to go somewhere where no one else has ever been before, that when you put your foot down at this point, you are going to be the only person that has ever put your foot down at that point. That is something that just, man, I'm getting goosebumps here sitting and think about what it would be like to have that opportunity. But now just kind of let's step back, and I want to think more globally, more not just from a personal standpoint, but what it means for us as a nation, what it means for us as a world, what it means for us as humanity. My youngest son is 20 years old. He has never known a time when there has not been a U.S. astronaut orbiting this Earth. And that's pretty incredible. I mean, for us to, we grew up when, you had the shuttle flights, it'd be up for 2 weeks and then they come back. And so to sit there and think about him not knowing any time when there is not an astronaut orbiting this Earth is pretty amazing. And so what Artemis, what this first flight that you're talking about happening hopefully in November or December of this year, that is the beginning of a time where we could have someone on the moon, someone on Mars, and future generations are never going to know a time when we don't have someone on the moon or on Mars. And so just think what that means, right? I mean, we sometimes take it as commonplace that there's somebody orbiting the Earth right now, that 7 of our colleagues are up there orbiting the Earth right now, and so this is the beginning stages of making that a reality as well. That there's going to be a time when there's always someone on the moon and always someone on Mars, and that to me is extremely exciting.
Victor, how about you?
I'm excited about the goals of the Artemis program, and I'm really excited about one facet of it in particular. And Hopper just went into the bigger points of it, but the fact that we're going to stay, that we're going to have a sustained presence of some sort, I think that's really important. And I am looking forward to whatever piece of it that we get to do, whether it's sitting in mission control, talking to the crew that's on the way to the moon, or sitting in a meeting and helping think through the problems that could arise and how we'll tackle them. All of us have a shot at being some part of this team effort, and I'm just excited to be here at this time. It is a great time to be in the space business.
So, obviously, an incredibly special time. Is there anything you'd like to say to your higher ups who might be watching about why they should choose you?
If that's all it took, things would look different. All of us would probably be in space right now. No,
yeah,
I think what they're using to decide has already been determined, right? The work's already been done, so their minds are made up in that regard. But yeah, we're here. That's all we can do is be here for them.
For sure. Can you talk about some of I know there's some new cutting edge technologies going into the Orion spacecraft and the Space Launch System. Can one of you speak to kind of how that's going to work and some of the technological advances that went into making this reality? Go for it. Yeah.
So I can talk to a few of the things, but I also want to put this in tension with this other idea that there are also some proven technologies that are going into it, which I think are really important. The rocket that's going to power this system. So Artemis is made up of all these ground systems, which there's a whole lot of. Then there's the rocket, which is SLS, the Space Launch System, and the spacecraft that people are going to be in is called Orion. And then there's a lunar gateway that is they don't like us to call it a space station around the moon, but it's kind of like a space station around the moon. And so all of those pieces, and then lots of other little science payloads. They call them co-manifested payloads that are going to be on the rocket that can come out in different times and go into different orbits. And so this system is powered by these solid rocket boosters that are similar to what flew on the shuttle. In fact, the technology, the hardware we're going to fly for the first missions is, I think, 4 missions. We have 4 missions worth of boosters that are going to fly, and then we have, I'm sorry, that's maybe the RS-25 engines, but those engines that are on the bottom of the core stage are the same technology that powered the space shuttle. It had 3 of them on the back of the shuttle. There are 4 on the bottom of the core booster, and those are going to, it's going to sound and smell very much like a shuttle launch when this thing launches. And when it launches, it'll be the most powerful rocket to fly. It's on the order of 8.5 million pounds of thrust. The only lift capability that could get a human-rated class spacecraft like Orion to orbit around the moon. And so, yes, there's a bunch of new things that are coming out. If you look at Orion, it looks very much like the Apollo spacecraft. It looks very much like the Starliner. None of them are as sleek as Crew Dragon. Resilience is the best looking one in my opinion, but they're all roughly the same. Physics has determined that the teardrop shape, that's physics. Physics says this works best on entry. And it also happens to work in the aerodynamic environment of going uphill for ascent, but it's really about entry in the thermal environment you come into with the heating. So the technology that's going into it, though, it's all brand new. We've got better computer processing than we did during Apollo days. We've got better understanding of the thermal system. So the heat shield on the Orion and the thermal protection system on the SLS rocket. There's all kinds of new technology going into that. But another thing that's also important is not just the technology. There's technology in this new system, and there are these proven pieces, and then there's also manufacturing that's bringing them together. And some of these things are being stuck together with new manufacturing technology. So that's another piece I think that doesn't get enough talk in these tech spaces, that sometimes you're not making a new thing, you're making the same thing or an old thing in a new way. And one of the technologies that we're using to manufacture some of this new space hardware is like friction stir welding. The FAA has recently approved friction stir welding for aircraft, and so you're seeing the aircraft industry embrace this technology as well. And so we're using it to make spacecraft, and so it's a much faster way, but also a much more like almost down to the atomic level way to fuse 2 pieces of metal. And so friction stir welding is a technology that is helping us to make things better, not just make new things, but to make things better.
Yeah, one of the things I think is exciting about from a new technology standpoint, Victor talked a lot about the things that are going to get us there. But one of the things I think is exciting is about when you get there, the in situ resource utilization that's going to have to happen. That's going to make these missions possible. And so that's something we really, I mean, I guess we do it in the sense of like we're in space station right now. We utilize the sun to get our power and things of that nature. But when we talk about taking advantage of the water that's on the moon and taking advantage of the resources that are on Mars to enable these missions, I think that's another area that is extremely exciting with from an engineering, from a technology development standpoint.
Can you talk a little more about the advantages of being on the moon and being on Mars versus being in a microgravity environment of space, Mike?
Well, I think the big advantage of like the moon, for example, we have this goal, and I think it's the right goal of eventually getting to Mars. But the moon, not only is it a great place for us to learn about, our Earth Moon environment that we live in, but it's also going to be that proving ground for going on to Mars. And so the idea of being able to test out these systems, these in situ resource utilization, to be able to do all of that in a location where home is not far away if something goes really bad. And so I think that is the advantage and the reason for one of the big reasons, I should say, for going to the moon is just being able to do that. And then the Mars, uh, again, we're going to get there, and we're going to learn about our solar system. We're going to learn about the universe and where it all started. And so I think that's also something that is a reason to go.
Great. So we only have a couple minutes left, so I want to sneak in some questions, from our audience and from the team here. Maybe some hot takes that aren't. I don't know if they're officially NASA sanctioned. I don't know if you can say that or not. But we got to start with billionaires in space, right? That's been all over the news, and the FAA just changed their guidance for what an astronaut is. So is Jeff Bezos an astronaut or not? What are your thoughts on that? Victor, we'll start with you. Put you on the spot. Sorry.
Okay, well, if you ask him, he's going to say yes, and that's probably the most important part of that answer is he's going to say yes. But I think when I start talking about this stuff with folks, I think first of all space exploration that's safe and reliable, that gets them up there, allows them to do whatever their mission is, and get back safely, is important. All space is good space. And I think, we're not allowed to work with the Chinese space agencies, but I think what they're doing is awesome as long as they're pushing the ball forward. And I think it's important that we keep safety at the forefront. So all these activities, as long as they're learning the lessons that we've learned, sometimes at the cost of blood and sweat and tears and human life, as long as we keep those things in mind. So, when I think about Jeff Bezos, more so Richard Branson, before he flew, but there were Virgin Galactic employees that had flown to space. And in trying to reach that goal of eventually getting them into space, whatever lines, people want to talk about what line, Branson went to this line, Bezos went to this line, we lived at this line. And it's not a competition. It's a system where all of those pieces, they work together well. But before those things happen for these space tourism companies, Virgin Galactic, they got that system developed by a company called Scaled Composites. And Scaled Composites created the mothership and the spaceship. And there was a test going on back in, I believe it was 2015. And they had a mishap, and on the rocket dropped and lit the motor. And as it was going uphill, they unfeathered, and the spacecraft opened up, and it was still under propulsion, and it ripped in half. One of the pilots was injured; the other one died. That pilot that died, his name was Mike Alsbury, and Mike Alsbury went to Cal Poly like I did at the same time that I did. And so when people start talking about lines, I think about he and his family. I think about him and his family. He didn't make it to space. But he moved the ball significantly forward. He opened doors that enable all of this stuff that everybody's talking about, but nobody's talking about Mike. But the Astronaut Memorial Foundation recently voted that they're going to put his name on the Astronaut Memorial. And I think that speaks volumes about the work he did and about the astronaut community. And so, that's what's important, I think, is that he was doing work to move the ball forward, to open doors to these new opportunities. And so Virgin Galactic's mission, I applaud what they've done, what Sir Richard Branson was able to accomplish, and what Jeff Bezos and his team have been able to accomplish is amazing. It's inspiring, and not the soft, fuzzy inspiring, but the inspiring that helps people make decisions, that helps our politicians give resources to NASA and NOAA, and allows us to let contracts with these partners to keep moving the ball forward and to create a future that's going to work for all of us. So I applaud what they've done. And if Jeff Bezos wants to call himself an astronaut, guess what we're going to call him? The man with the coins rules. He's going to be called an astronaut. And so,
Fair enough.
But I tell you this, if Jeff Bezos, Richard Branson, Hopper, and I go on a mission, I think the two of them, they're going to say, you guys tell us what to do, because they know what we do. And I think they respect our profession, especially given their recent experiences. They know how hard it was to do what they've done. Jeff Bezos required on a very highly trained, proficient ground team and a great set of hardware and software. Richard Branson had all those same things. And he also had pilots in the spacecraft and in the mothership that dropped them. So I think their experience has given them a heightened awareness of the importance of having a trained and proficient team, no matter what their job title is. Call them a passenger astronaut, call us NASA astronauts, it doesn't really matter. At the end of the day, we're all trying to do our best work to enable human space exploration and support the next generation.
Thank you so much. Words of wisdom for sure. Mike, since we're talking about titles and nomenclature a little bit, last question as we're running out of time. You were the first U.S. member of the U.S. Space Force to be in space, and I believe you swore in to the U.S. Space Force while on the space station. Can you describe astronaut versus guardian and kind of why the Space Force exists and what the purpose is behind all that?
Yeah, I mean that was quite an honor to to have that opportunity to transition from the Air Force, a career that I've loved, a service that I've loved to be a part of for over 27 years, and to be able to transition into the Space Force from space with General Raymond, the Chief of Space Operations there. That was a very, very special moment for me. I think one of the interesting parts about it was it gave us an opportunity as well to highlight the different missions between the U.S. Space Force and NASA, because I think it's easy to confuse the two and think we're one and the same, and the reality is that we're not. There's certainly we overlap in the same environment, but NASA is about the peaceful exploration of space, and the U.S. Space Force is about assuring that can happen and making sure that we continue to have access to space, and that we can do so. The United States and our allies can continue to operate up in space, and so very distinct missions. And so I think that was a great opportunity to be able to highlight the difference between those missions, and at the same time highlight that there is a lot of collaboration that does happen between our organizations. And so very special to be able to do that. Still working on Ike. I got to get him to transfer over, but we'll see how that goes. I got
Fly Navy.
That's right.
Hey, when the Space Force gets a football team, call me.
So any parting words of exhortation or advice for engineers listening to this episode now? Victor, any closing remarks that you'd like to share with engineers?
Can I?
Please.
I was going to say Hopper is our sage. He's going to really give some deep wisdom. So can I go first with my one easy one? Is that okay,
Sounds
Commander? Great. All right. Now, I just want to encourage. So since our audience is mostly technical engineering, probably also management and C-suite folks and stuff, but in a technical sense, I think those of us in the science and technology workforce have to think about some things. Early in our careers, we develop these reputations and technical competence, and that's important. But at some point, leadership and management becomes very important. I think those cannot be overemphasized. Those are vital. And one other thing that I think we are not very good at that we have to focus on and really make sure, because it's a key component to inspiring the next generation of the science and technology workforce, is our ability to communicate and to share what we do and to communicate in a way that's captivating. When we didn't fly the space shuttle for a decade, I used to tell people our job in the astronaut corps, one important job, is to catch the heart. The space shuttle launch used to do that. It would make people go home and read encyclopedias about thermal protection and propulsion and the emissions. And now we didn't have the launches doing that. And so it's our job to captivate the heart. And then we can talk about all the technical pieces. And so please take this piece about storytelling and communicating the challenges and the rewards of our professions to young people, especially seriously, because I think it's our job to replace ourselves. And we can only do that if we inspire those young kids.
Well, I'm not going to go second anymore. That's the last time you're going to go first.
He pulled a fast one on you there.
That was good. Hey, no, though, I will say, because, for all the engineers that are going to watch this, I'd like to say thank you. Because it is the engineers, the scientists, the thousands, tens of thousands of people on the ground that have made what Ike and I do possible, that have allowed us to go up into space and try and further human exploration. But I would also say, Ike talked about inspiring the next generation, and I would say that for the engineers out there, we need you now more than ever. We are not going to get to the moon. We are not going to go on to Mars without them. And so what they are doing is so critically important. And it's not only critically important, as I mentioned, for space exploration, but it's also critically important for just taking care of our own planet, taking care of Earth. And, we have a lot of challenges, and it's going to take engineers to solve those challenges. And so, again, thank you, and look forward to working with you in the future.
Yes, thank you.
Wow. Well, Victor and Mike, thank you so much for being here. And thanks again to Avnet for sponsoring today's keynote. Visit their website at avnet.com. Also, go check out the other sessions that are happening today and browse the exhibitor booths on the virtual trade floor. Those are live 24/7 all week. I love geeking out on 5G millimeter wave stuff, so I'll probably see you over in that session. And then I'll be right back here for tomorrow's keynote with Brandon Moak, CTO of Embark and autonomous driving guru. Thanks for watching. I'm Daniel Bogdanoff, and I'll see you tomorrow.